Okay, so we spent 4-1 kind of leading you up into slope and what slope is. So now we are going to proceed with actually getting into like the nitty gritty of it, and that's how can you find the y-intercept and the slope. All right, so two things that we got to find from a line from from data in a table, a graph, or an equation. So three things we're going to show you how we can find those two things from. So again, the slope is a number that expresses the steepness of a line, the ratio of vertical change to horizontal change, rise over run. All that is the same. Okay? Vertical to horizontal, rise over run. So many different ways you think about it. And there you can see the slope. Here's the line going this direction, the staircase, okay, that we used. And again, going upwards is the vertical change, going sideways is the horizontal change. Does the slope change if we take 2 steps away at a time? Okay. It keeps the same ratio, all right? But obviously the distance between each step doubles because you're talking about taking stuff away, right? If we were to take these 2 steps away from these two, it's still the same slope. It's just you got some things missing. And is the slope the same between any 2 steps? Okay. And that is yes, especially if it has a common slope. So we're going to get into this right now. Okay. So first we're going to start with the graphs. So describe how you can find the slope of a line using a graph. Okay. So we can do something here. So we got this line graphed. All right. We got 2 points. All right. The point 2, 4. I'm sorry, 2, 2, which is right here, and 5, 4, which is right there. Okay. So what we can do is we can pick 2 points, which obviously those are 2 points on the line, and you want to find the change of your y values and put it over the change in the x values. That's one way you can do it. So if I look, okay, so my 2 x's are right here, and my 2 y's are right here. So if I go for, again, going this way, because there's the point, right? 2, 2, 5, 4. So the change from 2 to 4 is what? 2, right? So rise would be 2. And rise is what number? Top or bottom? That's right, top. And then the change from 2 to 5 is what? 3. So our slope would be 2/3. So that's one way you can do it within the table itself. Okay? All right. We'll get some more practice, but now you also see the graph out here. So you can also do it with the graph. So if I go to this point, and I want to go to this point, I want to go, first of all, my rise. My rise went up how many? 2. My run went over how many? 3. And that's how I can find the slope of 2/3. So that's how I can do it in a table, and that's how I can do it in a graph. Sometimes you don't have both there for you. So you have to, you got to really, you really got to be careful with it. So let's try it. Try using just the graph here. I want you to try to find a line with a negative slope, and then I'm going to turn you loose on one. So again, here is our one coordinate, right? Right here, 1, 4. Okay? 1, 4 is right there. And then 4, 2, which is right there. All right? So what is my change, okay, from this y to this y? From 4 to 2, I'm minusing 2, right? Over here, this was a +2 change, right? As a +3 up here, while we had 2/3. Well, that's a -2, right? And then over here is a +3. So the slope over here is -2/3. And again, if I look at the graph, my rise is going actually downward. It goes down 2 and then right 3. So that down 2 is negative, and that's how I get a negative 2/3 slope. Okay? So down below, you're going to pause this video for just a second. So down below, it says describe how you can find a change in the slope of the line that represents the data in the table, and I want you to find it. Okay? So again, we kind of already told you how to do it in that first example, the line with the positive slope. So you guys are going to work on this problem for about 5 minutes as a team in your table. So with that said, we're going to pause the video, and I want you to find the slope for this. All right, so now that you looked, so again, what are we going to try to do? Well, we want to calculate the change, just like we said before, right? Calculate the change in the y values and put it over the change in the x values. So, if I go from 0 to 3, what's that change? 3, right? And then from 3 to 6 is 3. From 6 to 9, 3. 9 to 12, 3. So this is 3 all the way across, right? We call that a constant rate of change. It's constantly changing at the same time, right? The same rate. So again, we put that over. It's going upwards, right? So it's a positive 3. Now let's go to the y's. From negative 1 to 0 goes up what? 1, good. 0 to 1, 1. 1 to 2, 1. So all these are going upwards in 1, right? So our slope is 3 over 1. Now, we can also take that 3 over 1 and just write it as a whole number, right? Because 3 over 1 is really what? 3. So our slope can be 3. Okay? So that's how you find the slope of a table. Find the change in y over the change in x. Okay? Very good. All right, so now you are really going to get some practice on the back. So go ahead and flip your sheet over. Okay? So now you're going to find your slope. You're going to find tables. You're going to find equations. You guys are going to be rocking and rolling this section. So it says graphs, tables, and equations all represent linear relationships. Linear relationship is a straight line. Okay? Notice up top there's an important piece of information here, right? The y-intercept is where the line crosses the y-axis. It's the y value when x is 0. That's very important when we're going to do this little part here. So you notice I have graph 1, graph 2, table 1, table 2, equation 1, equation 2. So we'll do graph 1 together so you kind of know what you're doing here. So in graph 1, they want us to find the slope and the y-intercept. Well, again, the y-intercept is where it crosses the y-axis at, right? They just set it up above in this yellow highlighted area, right? It's not on your paper, but it's on my board here, right? So where does this blue line cross the y-axis? Right here, right? That's at 6. Now, we want to pick 2 points. Find another point on the line. Here's a point right here, right? My pen's a little off, but you can kind of see it right there, right? So let's count. It's going downwards, right? So we're down 1, 2, 3. So we're down 3, right 1. So that's negative 3 over 1, which is negative 3. So there's our slope for that line, right? So again, that's how we did a line. Let's try doing a table real quick. Okay, I'm going to turn you loose. We'll do the 1s, and then you guys will do the 2s together. How's that? So now we have table 1. Okay, look at the change in y. If I go from negative 10 to negative 7, is that going up or down, and by how much? Well, from negative 10 to 7, that goes up 3, right? Up 3, Up 3, because remember, as we get closer to 0, it's increasing, right? So down in table 1, the y change in y is 3, and the change in x, this is going up 2. 2, 2, 2, and 2. So our slope for table 1 is 3, the change in y, over the change in x, 3 over 2. Now, let's go back up to table 1, the y-intercept. Because remember, there was a very important thing here. This little part can help us find the y-intercept. It's the y value when x is 0. So look in this table here. I'm going to erase all this extra stuff here for a second. Where do you see x is 0? Right here, right? So this box is the x and the y value. So your y-intercept should be what? -1. Because that's where x is 0, y is -1. That's the y-intercept. That's how you see it in the graph. Okay, let's go to equation 1. Now remember, I gave you this equation in the very beginning, right? So m is the slope, and b is the y-intercept, the two things we're looking for, right? So in equation 1, where is the m? Right, it's the number in front of x, right here, 2.5. What's the slope? Y-intercept is, or what's the y-intercept? The y-intercept is the b, which is right here. So your slope is 2.5, and your y-intercept is 5. Now it says write an equation for graphs 1 and 2. Well, we're going to write an equation for graph 1. So if we know the slope for graph 1 is -3 and the y-intercept is 6, we're going to write y equals, we're going to write -3 because that's the m, right? X. And since the y-intercept is a positive number, we're going to write plus 6, right? Here's your m, your slope. Here's your y-intercept. Don't forget your x and your y. Those are variables. Those are very important to your equation. Because remember, the equation of a line is y equals mx plus b. All right, so now that you've had an example to do this, I would like you to take over and try to do graph 2, table 2, equation 2, and find me the equation of a line of the second graph. Okay, so I want you guys to work on that. You're going to hit pause. We'll give you guys about 10 minutes to work on this. We'll check in if you're done earlier. We will restart the video. But right now we're going to pause. All right, let's see how you did. So let's go up here to graph 2. We'll do graph 2 in green. How's that? So again, y-intercept. So again, where does this blue line cross the y-axis at? Right here. Pen just a little off at 6. So what's the slope? So find 2 points, right? So here's another point. So now my rise is going up. It's going up 3, which means it's plus, right? And over 1, which makes my slope 3 over 1, which is 3. So 3 is the slope on this one, on graph 2, instead of -3. All right, if you got that, good job. Now, table 2, they made you work a little bit for the y-intercept. So let's find the slope first. All right, our x values all increase by 1, right? From 1 to 2 is 1, from 2 to 3 is 1, from 3 to 4 is 1, 4 to 5 is 1, 5 to 6 is 1. Now if you look at the y's, right, this goes down from 4.5 to 4 is 0.5, down 0.5, right? And then this guy from 4.0 to 3.5 is down -0.5, -0.5, -0.5. So they're all -0.5. So if I have -0.5 over 1, isn't that just -0.5? It is. Okay. Your y values are going down as your x values are going up. So now, what is the y-intercept? Well, if these are going up 1, right? 1, 2, 3, 4, 5, 6, And I know that I got to have it when x is 0. So what if I just go backwards? Isn't that subtracting 1? Because if I go this way, I'm just subtracting 1 as opposed to going this way and adding 1, right? So it's the same thing. If I'm going this way in my y's and subtracting 0.5, if I go this way in my y's, I'm actually adding 0.5. So add 0.5 to 4.5, and what do you get? 5. And 5 is our y-intercept. If you got 5 for your y-intercept, that's great, because that was a tough one, and you got it. Good job. You saw the pattern in the table. Now the last one, they give you the equation, y equals 20 minus 3x. Now again, we know the equation is this, right? But what they did is they kind of wrote it backwards on you. They flip-flopped your x and your y-intercept. So right now, the equation 2 kind of looks like this. So the sign is always to the left of the number. So here is your slope. Your slope is negative 3, which means your y-intercept then, to the left of the number, there's nothing, so that means it's a positive. Your y-intercept is 20. So negative 3 is your slope, 20 is your y-intercept. Now way up above, we had to write the equation, right? Y equals mx plus b in graph 2. We found the slope, we found the y-intercept. Now you can just plug them into your equation. Your equation should have been y equals 3x plus 6, because that was the information we got in graph number 2, right? Because again, in y equals mx plus b, your 3 is your slope, your 6 is your b, or your y-intercept. All right, so you've used 3 different tools. Now we're going to go to part B. And what happens when they just give you 2 points on a line? So you have no visual whatsoever. You have no graph, you have no table, you have no equation. They just give you 2 points on the line. So instead of graphing it, there's a way that you can do this. I'm going to show you. So the points 3, 5 and negative 2, 10 lie on a line. What is the slope of the line? Well, again, it's the change in y over the change in x. So just work left to right. This is your x value, this is your y value. Okay, so go this way. So look at my 2 y's. So from 5 to 10, okay, we're going to take those 2 and we're going to subtract it. Okay, so 5 minus 10. Okay. And then we're going to do our change in x, and that's 3 minus, and then we got negative 2. Well, we learned about that a long time ago, so it's going to come into play. So 5 minus 10 is negative 5. And what happens when I take 3 minus a negative 2? I have a double negative here. Right, it turns to a positive. So it ends up being 3 plus 2, which is 5. So when I have 5 and I divide it by, or when I have negative 5 and divide it by 5, we get negative 1 as our slope for those 2 points. That line has a slope of negative 1. So now it says here, find 2 more points that lie on this line. Explain your method. Well, think about this. If you draw your graph, right? Okay. So 3, 5, if I just kind of give you a little, 3, 5 is right here, right? So negative 2, 10 is like way up here, right? Somewhere. So my line's kind of going this direction, right? So if I'm at negative 2, 10, and this is 3, 5, think about it, right? When I say my slope is negative 1, which means my rise over run, I can go down negative 1 and then over 1, right? Down negative 1, over 1, and so on and so forth, right? So look at 210. If I go negative 210, if I go down 1, that takes me to what on the y-axis? My y's would go down 1, right? Well, that would take me to 9, right? And then if I go over 1, Instead of going from -2, I go to 1. So this next point would be -1, 9. So that could be a point on the graph, because all I did, I took one of my points and I used the slope to go to the next point. Because the slope would always go to the next point on the line. All the points that the slope hits are on the line. I could also go to 3, 5 and say, okay, well, if I go down 1 from 5, that's 4, right? And if I go over 1 to the right, from 3, the next one over would be 4. So another point could be the point 4, 4. And we can literally do this all day, okay? Down 1, over 1, down 1, over 1, down 1, over, and just keep going on and on and on and on and on. So again, that's how we can use the slope to find more points on the line. So lots of things we just threw at you, right? All right, so we're on number 3 now, which is I believe, on your second page. So here we go. So it says, Lisa observed that any 2 points on the line can be used to find the slope. Is this correct? Yes. And the reason is because all you need to know is the vertical change, rise, and the horizontal change. It doesn't matter where the points are on the line. Okay, you can pick the 2 closest points, you can pick the 2 furthest points, it doesn't matter. So now, it says, what is the slope of a horizontal line? Explain. Remember, the line that goes this way. We talked about that earlier. That's no slope, right? Which means the slope is 0. Has no slope. Because I can't spell. There is no steepness. To a horizontal line. It doesn't go up, it doesn't go down. It just goes left and right. Right? A horizontal line goes this way. It never goes up and down. That's vertical. So a horizontal line never goes vertical. It's horizontal. All right? What is the slope of a vertical line? Now this is what I'm going to tell you. The slope, you need to know this. So this is something you got to remember. The slope of a vertical line is 1 over 0. And 1 over 0, we don't know, right? Like, for example, let me just give you a little division problem. If I divide 0 into 1, we know that that goes in 0 times, right? So why it's undefined is I can't take 1 and divide it into 0. We don't know what that exists. So mathematical rule is that it's undefined. And this is something that we rehash again in 8th grade. Okay, so 1 over 0, okay, because this line only goes vertical. It doesn't go horizontal. So you'll have your rise over your run. You will never have a run, and that's why it's undefined. Okay, so the x value never changes. And the y value is 0. And the run is 0. So those are 2 special cases here in Part C. 0 slope, horizontal line, undefined slope for a vertical line. 2 things you got to remember, because again, we will use it again in 8th grade. All right, moving on to Part D. Compare your methods for finding the slope of a line from a graph, table, and equation. Well, remember, from a graph, okay, right, we pick any 2 points, right, and then count rise over run, right, or what we call the change in y over the change in x. In a table, okay, we found the change, and again the constant change, in our y values, and put it over our constant change in our x values. And in the equation, well, that was the easy part, because the equation was this, right? Y equals mx plus b, which means, so the slope is m, and the y-intercept is b. So we just find out where those two things are on the in the equation, and we easily find the slope. We easily find the y-intercept. And to wrap this up, in previous investigations, you learned that linear relationships have a constant rate of change. As the independent variable changes by a constant amount, the dependent variable also changes by a constant amount. All right, the independent variable is another name for our x. The dependent variable is another name for our y value. Okay? A constant rate of change is another fancy word we use for slope. So how is the constant rate of change of a linear relationship related to the slope of the line that represents that relationship? They're the same. The constant rate of change equals the slope. They're the same thing. So how are they related? Well, they're the same thing. You can't get more related than the same person, right? So that's what makes them. They're the same thing. We just again use two different words to describe the same situation. Constant rate of change, slope is the same thing. All right, so there's going to be no homework, but expect homework on these sections tomorrow. I hope you found this helpful.